All right, our goal today, practice something old. How to graph a function. Let's start with the parent function. Y equals x. What did we start the beginning of the school year with? What was the parent function we started the beginning of the school with? Do you remember? Y equals x squared, quadratic, a huge part of the EOC. Now, when you think of y equals x, whatever you pick to sub in for x is automatically y. So if you're going to use our normal standard -1, 0, 1, it's going to be the y's, the range, -1, 0, 1. When you graph your parent function today, I think there's two questions where you graph the parent function and then you graph another function. So that is in what form? What is y equals x called? Do y'all remember? Good, slope-intercept form. Very good, slope-intercept form. Now, if I give you something else to graph, let's say y equals x plus 3. If I use the same standard -1, 0, 1, -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4. Always name your graphs just like we did earlier in the year. And if this is part, let's see, I'm trying to see how the answer. A was the graph on the homework. B is going to be your t-table. So A is going to be your graph, B is going to be your t-table, and C is going to be a description of what happened to change the blue graph, the parent function, into the new graph that is green, y equals x plus 3. What transformation took place? Plus 3. Excuse me. Excuse me. Excuse me. Up 3. And just like when we did quadratics, when the addition or subtraction was done outside of the parentheses, remember we put parentheses, x squared, they didn't put it in a quantity when it's outside, then it affects up and down. What if it's in the parentheses of the quadratic? It did left and right. So that part, very, very similar. What if I give you something with a little more to it? All right, let's do this one. Let's do example 2, just a little bit added to it. Remember that I know that you know this is old news. Nice lesson for the day before Thanksgiving. Get it all done, grade it, turn it in. No worries over Thanksgiving break. The parent graph, if it asks for it, goes on first. Y equals x. Now, two ways to graph this. You, of course, may always use a t-table. But what if I ask you to graph it by its slope and its y-intercept? Do you all have a memory or a yes, Harrison?
Well, I understand what you did.
Go ahead.
You put it down on the y-intercept, then you go down to right 3.
Okay, slow down. What would you do to the y-intercept? I didn't catch that part.
You would just graph it.
What do you mean just graph it? Give me some details.
-1 means 0, -1. So
Oh, okay. So you get an ordered pair from the B. All right. So you are saying that it's not really the -1. It is really an ordered pair 0, -1. That was very nice mathematical explanation. So we will start with our y-intercept. Perfect. Now, Harrison, take it away.
then you can go down to right 3 is the slope, or you can go up 2 and left 3.
Down to right 3. So, on the homework, A would be your graph. This time we don't have a t-table. B would be that you use your slope and your y-intercept. And C is going to be the description. How did that change from the original graph? What happened to the y-intercept? Let's talk about it first. How did the y-intercept move? Good. The y-intercept went down 1. What did the negative sign do to the slope? Good. So now it's going decreasing. So the first paragraph is always increasing. Now the negative in front made it decreasing. What else happened to the slope? Instead of being up 1, right 1, now it is down 2, right 3. Perfect. Instead of up 1, right 1. Now, there's another bonus opportunity. What 2 bonus opportunities are running right now? The restaurant, remember, find a combo meal while the a la carte is a better price, and the exact change. If you are going shopping, if your family's going shopping over the Thanksgiving holiday, make sure you tell them if you get a perfect receipt to give it to you, because you can bring it in for bonus. Now, what do I mean by a perfect receipt? And it has to have tax. Why? Why not just go to the gas pump and let you fill up and put $45 in your car and bring me that? Theoretically, but couldn't you? Couldn't you? Couldn't you? And what is the purpose of having someone do math when they're not in math class? You might use math. My son in the car this week said, I don't know why we have to learn algebra because you're never going to use it. I wait for the opportunities, and then when he says something, I'm like, oh, you just used algebra. Oh, you're wrong. It's a great thing to do math when you're not here. In the old days, long time ago, when your grandparents walked uphill to school both ways, you know, have you heard those stories? Like, people cooked together in the kitchen, so it was nothing for a kid to know how to triple a recipe that was 1/4 of a cup. Because math was done constantly together. It wasn't something that you learned just in a classroom. It was something that you did constantly. So it's just, that bonus is just an attempt to get you to do math while you're not in math class, okay? The new bonus opportunity is called the Slopey Pokey, and I will be teaching it to you. It was Mr. Dowdy's idea that you must post it on social media, okay? So, it was. I thought it was awesome. Because my idea was that you had to stand on the cafeteria tables and sing it. Okay? Then post it on social media? Oh, this is going to make you famous. So today I'm going to teach you the Slopey Pokey. It has actions. It has a dance.
I might actually do this.
And we'll see how it goes. You have to split the points if you make it together, but yes. And I'll tell you these 2 are now excluded from the bonus opportunity because they're arguing with the gift giver. 10. We'll go over it in a minute. I'm going to teach it to you first.
Wait, so we take a video of ourselves singing and post it?
Let me say again, we'll talk about it in a minute once we finish this. Settle down. Thank you for being excited about it, or mad at me, I can't tell which. Standard form, 5x plus 2y equals 10. The fastest way to graph from standard form is not to put it in slope-intercept form. It is to use the x and y intercepts. Please tell me what an intercept is. X or y axis. When you say intercepts, it means 2, and there's could be one on the x and could be one on the y. In order to hit the y-axis, you have to have x be 0. In order to hit the x-axis, you have to let y be 0. So you can just, from the get-go, set up your t-table. X has to be 0 on one of them, y has to be 0 on the other. Plug it in. 0 times x is 0. 0 plus 2y equals 10, so y equals 5. And then y equals 0. 5x equals 10. X is 2. Do you still have ordered pairs? Sure you do. Yes, ma'am?
Will it always work when you can just switch them, or do you always have to work on it?
What do you mean switch them?
Like for y it equals 5, but x is 5 in the equation.
No.
And then
Mm-mm.
x equals
That's just, no. If there's a shortcut like that, I don't know it. But there could be, because I don't know, I'm not a shortcut finder very good. So if it asks you to graph by the standard form, the fastest is to find the intercepts. There's 2 special cases to review, and then you guys will be ready to work.
But how would they,
It doesn't ask you to compare. Like this particular part of the homework doesn't ask you to compare the y equals x to the other, but how would you do it? What happened to this question? Well, in order to talk about it, you'd have to graph it exactly and put it in y-intercept form. Okay, Wes, which I don't ask you to do that on that section, but you could find out what happened to it that way. What are you going to do with this one? Special case. What are you going to do first? Solve for y. What kind of special case is only equal to y? Vertical or horizontal? If you have only one letter, and we talked about this, we did this with inequalities, if you have only one letter, whatever that letter is equal to has to be the only thing that letter is equal to. So if it says y equals 3, that can only equal 3 in the y position. We've done questions much, much harder than this. We did shading, we did combined shading. This should seem very easy to you. Y equals 3 is a horizontal line. It has a slope of 0 and a y-intercept of 3. It's neither decreasing or increasing because it is horizontal. What did you say?
Well, I just feel like we should do more on it, but
I know, that's it. There's nothing else to do. How would you attack this, Hunter? Good. X equals 18. Because X is the only thing given, what has to go in the t-table everywhere you have an X? Got to be 18. So my tick marks are going to be at 9 and 18. So I'm going to go to 18 and go down 1, stay at 0, go 18 and up 1. This guy is equal to X equals 18. He is vertical. His slope is undefined. And he has the null or empty set for his y-intercept. Why is there no y-intercept? Yeah, never. It's parallel to it. That's right. Perfect. Keandre, perfect. Bless you.
can we do it on the back of this?
That's the goal. I'm writing down the directions just because they kind of change on those. All right, so on 3 and A, you're going to do A, a graph, B, a t-table, C, explain the difference in the parent graph and the new graph. 15, 34, 41, 46, and 50, you're going to graph and give a t-table. On 59, let me look at that real quick. 59, you are going to work it out and give a final answer, so you'll show work on 59.